model-based 3D breast surface reconstruction from monocular RGB videos. So 3D breast surface reconstruction or imaging is expensive, and the domain is largely dominated by commercial 3D scanning solutions from companies such as Artec, Canfield, 3DMD. These scanners are quite costly, and they involve special hardware and software. So these are quite big numbers, and as you can imagine, not every hospital or clinical facility is actually able to afford such a system. To mitigate some of these problems, we propose a cost-effective and accessible metrical breast surface reconstruction pipeline that only requires a single monocular RGB videos input. So our method does not need special hardware, nor does it rely on closed source software. Everything is just freely available, open source, and fully transparent. We introduce a real-world scale neural parametric breast model that has been trained on over 160 high-quality 3D breast scans, which we then use as a prior for metrical and model-based 3D surface reconstruction from RGB videos. So the input is a 180-degree video that is captured by moving in a circular motion around the patient. The output is a metrically correct 3D reconstruction in form of a triangular surface mesh. First, we run a state-of-the-art differentiable structure for motion pipeline. This gives us a sparse point cloud and camera poses. We then require the user to select 6 landmarks in a single image only once. We back project these landmarks into 3D and align our model's mean shape to the SFM-generated point cloud. Finally, we fit our model to the point cloud using simple Latin code optimization. So our model instead employs an implicit representation in the same way as the IRBSM does. We decompose the implicit breast domain into multiple smaller regions, each of which we model using a local multi-layer perceptron, which is centered around an anatomical landmark position. So this strategy allows us to model high-detailed breast geometry, including nipples, small skin folds, and belly buttons. Overall, we find that our reconstruction pipeline is able to achieve an average reconstruction error of less than 2 mm when we evaluate in a metrical setting. So compared to the ground truth Vectra H2 scan, which we show on the left, our pipeline reconstructs detailed breast geometry, including fine anatomical structures such as skin folds, nipples, and belly buttons. We evaluate our reconstruction accuracy as a function of the number of input views that we extract from the video. So overall, we found that in our experiments, 30 images works best, and this presents also the ideal trade-off between speed and accuracy. So one drawback of our method is that we require the manual selection of 6 landmarks during the alignment phase. So lastly, as future work, we'd like to evaluate our pipeline in a clinical setting based on common anthropometric distances and volume measurements. And also we would like to explore fully end-to-end trainable pipelines as common in the phase domain, for example. We've presented a new 3D neural parametric breast model, and based on this model, we developed a cost-effective and accurate 3D breast reconstruction pipeline that requires only an RGB videos input. We also provide an easy-to-use graphical user interface that runs on macOS and Windows. And finally, our model and our pipeline is fully open source, and it is publicly available.